Okay, everyone, welcome back from the break. I was just looking at the session that we have in front of us, and I'm like so excited about what we're going to see this next session. So let's kick things off. I'm going to start things by giving us the third announcement of the summit. So the third announcement of the summit is a project we're calling Dandelion. And let me first, in usual fashion, rather than telling you what it is, I'm going to tell you why we're doing it. And so we're very interested in the Dandelion project for this reason. And what this is an illustration of scale of federated learning systems colored by whether they're open source and we can inspect them, we know they work, or whether they're closed, either written inside a paper, or maybe they're in some sort of production environment. And so the blue dots here are showing us a variety of papers at different scales. The first thing we immediately see is that these blue dots are relatively small, given the ambitions of federated learning. We're trying to build systems in theory that are on the scale of millions of clients integrating information. And what you'll realize, these blue dots are typically running at scales of hundreds of clients, maybe thousands of clients. So the scale is very small. And simultaneously, the number of colored objects that are yellow, the ones that we can inspect, we can see how they actually run because they're open source and they're live, are very, very few. And so the takeaway message here is in the federated learning space right now, there's not many systems that are of large scale that the community can really look at and inspect and see how they're running and learn from. And what makes matters worse is this really other interesting dimension, and that it's not like we lack truly large scale federated learning systems. If we look at folks like Apple, we look at folks like Google and other manufacturers I could, or another couple other manufacturers I could show, they in fact have systems running at this scale. So this is a log scale running on this y-axis, on this x-axis. So we're talking about, in the literature, we're seeing systems that top out at around 1,000 or so. But yet we know in reality, there are systems up in the tens of millions, hundreds of millions, but they are completely closed. We don't know how they function. We can't learn from them. And so this is not a healthy environment for an ecosystem to evolve. And so this is where Dandelion comes in. Dandelion is a partnership between Brave and Flower. So Brave, as we heard yesterday, Brave is a fantastic federated and privacy-preserving team. They really know what they're doing. And what Flower is going to help work with them on is providing them with the raw nuts and bolts that they can then use to build a system that we're calling Dandelion. That's going to be the combination of showing the world a federated learning system at scale that has a degree of transparency that they can start to, that the world can start to learn from. And so it'll take a while to build things out. And momentarily, I'm going to hand over to Stefanos, who's leading the project, as well as Lorenzo. Lorenzo. But when it finally manifests, we're hoping that we're going to see a system unlike anything you've seen before, where we have 60 million real users, the Brave browser users, using a system where components are using federated learning. And this will be the world's largest open source federated learning system. That will be a tremendous step forward for federated learning as a domain. And so by that, as an announcement, I'm now going to hand over to Lorenzo and Stefanos to give you all the details of what they're doing over there at Brave. Stefanos Laskaridis. Yep. And Lorenzo Minto, they're the driving forces behind the Dandelion project from Brave. So Stefanos, as you saw yesterday, he presented us a different piece of work, a real novel piece of research. And today he's going to be talking about a more practically focused but highly influential next step.
Then present the Dandelion. This the infrastructure for privacy preserving cross-device on Brave browser. So a few words about that. I studied on Brave before I was a company here at Cambridge. I did my intern in Cambridge, and before that, my interest probably will be a better learning, distributing about systems as well as business habits.
He's an engineer at Brave, and previously he did an internship in Twitter, and he did his master's in UCL and bachelor's in the Politecnico di Milan. His interests are around the applied ML areas, federated learning, as well as NLP. Right. Also, we have Minos in the back, who is also part of the project and a researcher in the same team. Right. So a few things about Brave that you might not know. So Brave offers a private alternative to big tech. So we think that like the kind of point that the web has converged right now is slightly off. And we think that it should be more private and more wary of the attention of the user. So we offer a lineup of products that start with the browser that was created effectively by Brendan Eich. He's the creator of JavaScript and the co-founder of Mozilla. And we also offer a search engine, a reward system for paying effectively creators through cryptocurrencies, that is BAT. We have a wallet that is exactly for crypto. And then we offer also a firewall and VPN service, Brave Talk, which is an equivalent of Google Meets, if you may, but a bit more privacy preserving, let's say. A news aggregator, and Brave Playlist, which is a way of consuming content offline without seeing ads. Right. Yeah. So starting with the Brave browser, it is private by design. So that means that we have an integrated ad blocker, and we block fingerprinting of users. So we don't want to identify specific users in the web and their breadcrumbs around when browsing the web, and as well as the third-party cookies. So yeah, you can see here that a visualization of the shields that you might see inside a website. It's an open source project. It's Chromium based, and we also allow for routing through the Tor network, and it's available in all the major platforms that you can think of. Right. So we, as I said before, we think that the ads ecosystem is slightly off than it should be. So we offer an alternative. The alternative is to be wary of the user's attention and offer ads only as an opt-in, either through the landing page, that is like the new tab page that you see, or through ad notifications, or even the search engine. However, the matching of the user's interest to the ads are done purely on device. That means that we have no data collection about the user preferences, and also the users who opt in, they receive 70% of the revenue in BATs. This is the basic attention token because it's tied to attention. Right. We also have Brave News, which is doing private news curation inside the browser. It also involves no tracking. So we're not tracking like the interest of the user actively. And we can offer personalized ad matching through and anonymous ads to the user. Right. And Dandelion. Dandelion is the infrastructure, a different model of federated learning deployed for the Brave's browser. The infrastructure that you see here resembles what we have seen many times before for federated learning, but it differs in a very core idea that the connections are initiated by the users, by the clients instead of the server. So we cannot actually address single clients, but they are only participating in the federated training process through a subscription-based mechanism, and they ping effectively the server whether they have something to train on. Being privacy sensitive means that there are certain requirements for deploying any federated task. That means, and depending on the features always that are involved. So the requirements are broadly involve secure aggregation, local and or global differential privacy, as well as blinded tokens for robust participation in order to verify that a client has participated or not, but not knowing like which client it is. Right. So there are certain unique challenges in the way that we're deploying federated learning, meaning that we have no addressability of individual users, as I said before. The participation is initiated by the client, and there are certain actually features that either require explicit opt-in or they are out of reach altogether because of their sensitivity. Last, we cannot train in a way that interferes with the browser. So we cannot have the browser just lagging, as you saw before. You cannot have the browser interfering with the quality of experience of the user. Exactly that, Apple. And yeah, the training task actually needs to be mostly in the foreground, meaning that, well, when an application is scheduled when it's not in the foreground, it's in background, meaning that you have another application being in the foreground, you get scheduled differently in the Android or iOS operating system. So that means that we need to take advantage of like the time that you have in the foreground in order to do any computation, and then move to the and then upload the updates to the server. So I want to invite now Lorenzo to talk about the use cases.
Okay, so yeah, minding the delay. So yeah, I'm gonna just illustrate some of the application that we see for federated learning in the browser, and yeah, it's a better framing. And just as a reminder, as Stefanos explained, we are like highly privacy focused. So the Brave's privacy policies don't allow us to mostly connect any centralized data. So for us, centralized ML isn't quite never an option, and therefore FL really constitutes the baseline, which is unlike a lot of other deployments or actors that do use federated learning, which use it as a way to augment like centralized baselines. And so yeah, I'm going to go through some applications. Some of these are we are actively working on. Some others are we are planning to work on as future work. And one of the first one is ranking optimization. So this is Brave News. This is the mobile version. Well, Brave News is presented as a feed both in desktop and mobile. And as Stefanos said before, it's a privacy-preserving news aggregator, which resides on the browser. All the signals are collected in the browser and are used strictly on the browser. So one of the way that we rank like the cards in the feed right now, it's mostly heuristic based. So we're using it's a rather simple heuristics with hard-coded sort of domain knowledge directed coefficients, and we have several signals that we can consider. Of course, you can look at recency, you can look at popularity, but you can look at more like focused and user first signals, like if the user has subscribed to a particular source, or if the user has clicked on particular type of articles. The fact is, the more signals you have, and also as the feature evolves, you're going to have more signals that you can count on. The harder it is to really weigh together all these signals. And so a heuristic really makes sense up to a point, especially when it's not like informed by data, which and especially the weighting. The weights are not data informed. So in order for us to really tune this heuristic, we will need to collect data such as like the articles that you read, or the sources that you like, and which we cannot really do. Therefore, FL is like a very fitting application where we can remotely fine-tune these parameters, either through federated learning or federated tuning, and we can sort of come up with a better heuristics, which then would ultimately make the feed experience more personalized and ultimately better, also leading to higher retention in the particular feature. I should have switched slides before. Another application and another focus of federated learning at Brave is in ads, which is like a kind of an important application for us. And one of the way that we rank ads right now, it's kind of a ranking problem. It's a kind of a recommendation problem as well. So right now we have different types of serving strategies. You can think of like purchase intent as being a serving strategy. We use a text classifier to infer a local text classifier to infer interest segments. And more recently, we've been working on like embedding based methods for like ad matching. And okay, And so also here, just as before, the way you put together these signals, it's not, it can be domain informed, but it's always like, also because it's not data informed, it's always like a huge limitation. So even here, the goal is again, like understanding how to mix these different strategies together, whether like treating each of these signals as a feature themselves or just aggregating them in a single bigger model, which you can then like train on federatedly. Another application for ads, I think I got it. You just basically need to switch by 2. And another application for ads, it's like understanding when it's best to deliver an ad. Right now, the system are mostly rule-based. So for example, you can imagine don't serve an ad between this and this hour because it might be disrupting for the user because let's say they're working, or don't show an ad because the browser is in full screen mode, something like that. These are like strong limits, and since we don't have the data, again because of brave privacy first commitment, then we federated learning sort of comes to the help to understand like more fluid boundaries on what like it's an opportune moment for ad delivery. And also like another option could be to increase the sort of serving analytics that we get, but that would also increase the fingerprintable surface for the user, which is also something that we don't want. So federated learning like seems, with the appropriate privacy preserving mechanism, seems like the way to go for these particular applications as well. And okay. Okay, and another application, it's on the Omnibar. So the Omnibar, it's a name derived from Chromium, and it's the search box that you use to like what you like go to do your searches. And it's something that people sort of most of the time take for granted, but how those things are ranked can be quite impactful, because if a suggestion is relevant and it's easier to get to by either just clicking enter or just using the arrows to reach it, it makes it for like a better UX. So a way that also that system, that ranking system, is derived from Chromium, I think is and it's a very complex heuristic, again, heuristics mostly, and it's very structured. So it's kind of hard to really intervene and say, okay, let's try to make this better. Let's try to add new features or new things that could be recommended in the area. For example, you could have something like start a doc on Google Docs rather than having like just the history of things you visited before. And so that's another like very fitting case for federated learning. Imagine that you had to train that centrally, you would have to collect essentially browsing data, which is even for other browsers would probably be too much. This is also a very nice use case together with the news one because of the high feedback. So you're going to get a lot of data because these are kind of used extremely frequently. So you would get quite a lot of sort of labels and supervised samples. Finally, something that this is more future work. And another thing that we've been kind of interested into looking at has been like next activity suggestion. It's kind of inspired by the Siri suggestion that you get if you're an iPhone user. And on the right, you can see it's the sidebar. So this is kind of a lesser known feature, but it becomes quite helpful when you have like to quickly access certain websites. So you can either pin them there, or if you had like an interesting or an actually good way to do next activity suggestion, you could just start sort of suggesting the types of websites that you might want to visit next. And this is because browsing is most of the time habitual. It can be either habitual or or like goal driven. But in the habitual case, for example, like news, so browsing in the morning, or financial, or like checking the financial markets, then these activities can be made like, can be kind of optimized by surfacing on the sidebar the relevant the relevant website you might want to visit next. And things to consider in this case are contexts such as the time, the active tabs, what do you have on your active tabs, and sort of historical activity. And so yeah, this is another of the use case. And I think that's pretty much it. Yeah, big thank you. Thank you for listening. Thank you for Flower, for the Dandelion partnership, and also, yeah, a reminder, it's not here, but we have internships next summer. So if you're passionate about privacy preserving ML or federated learning, please reach out to us. Thank you very much.
Yeah, interesting. We have time for a couple of quick questions. If there are some in the audience or online. In the back.
So you mentioned like potential progress and like how federated learning stuff in that case. Are you planning like to develop all of the models at once, or like get one problem by one and solve them?
But so the question is, you mentioned quite a few problems involving these things out. So how are you going to approach it? Are you going to bang things out all in one go, or are you going to incrementally build them out?
Right. Well, the first step, I guess, is laying up the infrastructure, which is the most important step, and then we can have like multiple use cases being launched at different, let's say, paces in order to validate essentially the hypothesis of privacy here. Right.
There's a question from Dennis.
Thanks for the very nice talk. I have a question regarding the users. So is there an incentive mechanism that incentivizes users to take part in federated learning? And when do the models actually train? Is it when they're plugged into the plug, or?
Okay, so two questions. Is there incentives for users to use this thing? And if they are using it, is there some timing mechanism about when they're trained or not?
Mm-hmm. Great questions, both. I can first answer the second question, which is a bit easier, not to deploy, to answer. It depends. So the eligibility criteria might have to do with, so let's say the desktop case, the laptop case. It might be when it's plugged in and connected on an unmetered connection. Whereas when we're talking about the device, as I said before, we might need to take opportunistic moments that the browser is actually in the foreground. So that might affect the eligibility criteria, and you might want to train something quickly, but being battery powered. And obviously this has repercussions like in the scheduling system of Android or iOS, and the way that, and how much horsepower we have. And then on the incentives, do you want to take that one, or I can?
Right.
All right. So the incentives go hand in hand with the utility. So you cannot have like the utility of a model that is globally good or even personalized to you without being part of the federation. So I would say that this is the biggest thing that they get out of it. Now, if this can be theoretically coupled with other types of incentives, such as, for example, getting path tokens, that's a different discussion. I'm not saying that we're doing this. I'm saying that it is up to discussion and not at my level to decide.
So
yeah.
There's one online question, which is, there was something around ad revenue sharing. How do you identify users, maintaining users' privacy? I guess it's about how do you pay them without violating privacy.
Right. We don't pay a user like as in like John Doe. We just pay a specific address, a specific wallet. So we don't really tie how they're browsing with what they did, right? So yeah.
Yeah, it's a blinded token system. So based on privacy pass.
Okay. Well, thank you both for telling us a little bit about Dandelion.